Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 5, Notes 3. Today we are talking about the quadratic formula. So over the last couple days we've been actually graphing quadratics, graphing parabolas, and taking a look at the parts of the parabola and how we interpret those graphs. Today we're going to learn an algebraic method for solving quadratics. So using the quadratic formula, this is not involving graphing, but involving algebra instead. So let's just review finding the square root of things and using our order of operations up at the top of your page. If I look at number 1, I'm looking at the square root of 16. We know that the square root of 16 means that I want some number times some number that gives me 16, which is 4. When I look at something like the negative square root of 25, I want to take the square root of 25 and get 5, and then I want to multiply that by negative 1, so I actually am looking at negative 5 here. So square root of 25 is 5, negative out front makes it negative. Take a look at number 3. I have the square root of 34 minus 2 times 3 times 3. Now, order of operations tells me that I need to multiply before I subtract. So I'm going to multiply those 3 together. 2 times 3 times 3 gives me 18. So this is actually the square root of 34 minus 18. And then I can go ahead and subtract. 34 minus 18 is 16. And the square root of 16 is equal to 4. Plus or minus, this little symbol right here, that's probably a symbol you have not seen before. That is read plus or minus. That really just means that we want both varieties. We want the positive version of the square root of 49 and the negative version of the square root of 49, because there are two different possibilities that give me when I multiply a number by itself that give me 49. I can take 7 times 7. I can also take negative 7 times negative 7. So in this case, I'm looking at plus or minus 7 for my answer. You could also list that as 7 comma negative 7. Both of those mean the same thing. But you're looking at both versions there. You want the positive version and the negative version. Let's take a look at 3 squared minus 4 times 2 times negative 2. So again, and the square root of that. I want the square root of that whole thing. Again, I need to use order of operations under here. So order of operations tells me do the power first. That gives me 9. And then it tells me to multiply. 4 times 2 times negative 2 gives me 16. So I have minus, and actually that's a negative 16 because that's a negative 2, minus negative 16. That minus a negative is actually plus a positive, so that's the square root, and I should have had my radical there. Square root of 25, and the square root of 25 is equal to 5. Now I have some things outside of the radical, outside of the square root symbol. So negative 7 minus the square root of negative 5 squared minus 4 times 1 times 1. Now I want you to be very careful with things like negative 5 squared. When you plug that into your calculator, use the parentheses. That will make a difference. If you don't use the parentheses when you plug that into your calculator will square the 5, and then it will multiply by negative 1, and it'll tell you that the answer is negative 25. But we all know if we take negative 5 times negative 5, I get a positive 25. So you need to make sure that you use parentheses when you type that into your calculator. But a lot of us can just do this piece in our head, so we don't really need our calculators here. The negative 7 minus, that's out front, I'm not doing anything with because I gotta simplify underneath the radical first. So this piece gives me positive 25. This piece, negative 4 times 1 times 4 is negative 16. So then I need to do the subtraction. Negative 7 minus the square root of 25 minus 16 is 9. Then I need to take the square root, negative 7 minus 3, and that gives me a negative 10. When I take a look at the last one, 11 plus or minus the square root of negative 7 squared minus 4 times 5 times 2. So this is again where we see that plus and minus symbol. That means we want the positive version and the negative version, or in other words, we want to add and subtract right there. So I need to first simplify under the radical, and again use parentheses for that -7. So -7 squared is positive 49. So the 11, oh, that's hard to see, 11 plus or minus, and then the square root of positive 49. Then do this piece. -4 times 5 times 2. -4 times 5 is 20. 20 times 2 is 40, so minus 40. That's what I'm looking at there. Subtract, because I still need to simplify under that radical first. So 11 plus or minus, 49 minus 40 gives me 9. So I want the square root of 9. And then we all know that the square root of 9 is 3. All right, so now what happens here is you actually split this off and get two different answers. I need to make one of my answers 11 plus 3, and I need to make the other answer 11 minus 3. So 11 plus 3 gives me 14. 11 minus 3 gives me 8. My two answers are 14 and 8. Okay, so that's just a preview of kind of what we're going to be looking at today and some of the order of operations that we're going to have to work with today. Now let's get into the quadratic formula. So here's a picture of the actual quadratic formula. The quadratic formula looks like that. It is read like this. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, and that whole thing gets divided by 2a. It's a lengthy formula. It's long. That's no secret. There's a lot of pieces to it. However, the nice thing about the quadratic formula is that the quadratic formula always works. You plug your a, b, and c in, you simplify the right side of that, and you have your answers. You don't have to guess and check with your factoring. You don't have to plot points on a graph and guess where they're crossing the x-axis. That's the nice piece about a quadratic formula. So this is our third way of solving quadratic equations, and while the formula is lengthy to use and it takes a little bit of time to process, it's foul-proof. It always works, and we can use it every single time we solve a quadratic. And that's the nice piece, because it's not always reasonable to graph, and it doesn't always work to factor. So let's just talk about what the quadratic formula does for us. This formula gives us the roots or zeros or solutions or x-intercepts. All of those words are interchangeable, and you'll hear and see all of them. These words all mean the same thing. Roots, zeros, solutions, x-intercepts. Most of the time we've been using the word solution, find the solution to the equation, but just know that all of those words mean the same thing. The equation has to be set equal to 0 in order to solve. I need everything on one side of the equal sign. So that's a piece that we'll have to work through. And then we can use this in place of factoring and graphing like I talked about on the previous slide. So this is just a third way for us to solve quadratic equations. Let's talk about some steps. The steps to using the quadratic formula. First of all, we need to figure out what a, b, and c are. If I'm going to plug a, b, and c into that formula, I need to know where they come from. If you don't remember, think back to notes 1 of unit 5. Our quadratic equation looked like ax squared plus bx plus c. That's the standard formula of a quadratic equation. So your a is always with the x squared term, your b is always with the x term, and the c is always the constant. Next, we're going to plug a, b, and c into the formula, put them in the spots that they need to go in. And then we need to simplify. Use your order of operations. Some of us don't remember those. We are going to do them a lot today. Use your order of operations in order to simplify this equation, and then round your answers to 2 decimal places, because a lot of times when you're taking the square root of something, especially if it's not a perfect square, you're gonna have a decimal that continues on, and we're gonna have to round it off somewhere. So I typically round it off to the 2nd decimal place. All right, so let's just go ahead and try some. So number 1, I have 3t squared minus 7t minus 20 is equal to 0. So the first thing that I want to do is figure out what is my a, my b, and my c. Well, a is always with the t squared, or the x squared. In this case, it's t. B is always the -7 with the t term, and c is the constant. So a equals 3, b equals -7, c equals -20. Okay, so then the next thing I'm going to do is I'm going to plug them into this long formula. Now we're using the variable t here instead of x, but it doesn't matter. We can use whatever variable we want. You're going to see t a lot because a lot of times we're talking about time. So that's why sometimes t is our variable. Okay, so t is equal to, now I want the opposite of b. If b is -7, I need its opposite, and its opposite is +7. That's plus or minus the square root of, then I need b squared, put it in parentheses, just always put it in parentheses so that you know that it has to be in parentheses in your calculator. So -7 squared minus 4, that 4 is always there, times a times c. This whole thing, not just the radical, the whole thing is over 2 times a. So very often students want to just put the fraction bar underneath the radical. It's not only underneath the radical. If you take a look up at your formula on the first page, it's under the whole, oh, where'd it go? Oh, and it's covered. It's under the whole thing. That fraction bar goes under the whole thing. So you need to check and make sure, is your fraction bar under the negative, under the b term that's out front, the opposite b? So mine is. Now I need to go ahead and simplify. So this is me plugging it into the formula. Now there's a lot of things in here. There's a lot of steps to simplifying this expression, this side of the equal sign, but I just need to take it one piece at a time. So you're going to see me go through all of the pieces of simplifying this. I have to start under the radical. I have to. If you need to write that down to remind yourself, do it. Start under radical. And then even within underneath the radical, I have a power and I have multiplication and I have subtraction. There's just 3 things to do underneath the radical alone. So that's what I'm going to start with. So the 7 out front doesn't change. The plus or minus doesn't change. Underneath the radical, I can take -7 squared. That's going to be +49. Be careful typing that into your calculator. You have to use parentheses. And then the -4 times 3 times -20 gives me a positive 240. -4 times -20 gives me positive, and then I have a +3 as well. So this is now plus 240. Whole thing is still over 2 times 3. If you want to go ahead and put that 2 times 3 together to be 6, you can do that. We can most of us can do that in our heads. I'm still under the radical though. I haven't finished that. So 49 plus 240, 7 plus or minus. 49 plus 240 is 289. Still all over the 6. Notice my fraction bar. It's under the b that's out front. Make sure your fraction bar goes under the whole thing. Okay, so now actually take the radical. Take the square root. So in your calculator, you're going to type in the square root of 289. Now, most of you use scientific calculators in this class. Your scientific calculator has the square root key. It's a second function, and the button is on the left-hand side above the x squared. So you need to hit second and then the x squared and then type in 289. Check that on your calculator. Make sure you can find where that is. And the square root of 289 happens to be 17. So notice I still haven't done anything with the 7 out front. I still haven't done anything with the 6 on the bottom. Once I take the radical, my radical sign is gone. Okay, notice I have the square root of 289 up there. I took the square root of 289. Now I have no more square root symbol. So be careful with that. Here's where life gets a little bit interesting. So I need to split this into 2 equations now because I need to have one equation where I'm adding the top and one equation where I'm subtracting the top. So that's where I'm going to split these. Notice I still have not done anything with the bottom, the 6 on the bottom. So I have one equation that looks like t is equal to 7 plus 17 over 6, and another equation that looks like t is equal to 7 minus 17 over 6. So now I need to solve both of those. 7 plus 17 is 24. And 24 divided by 6 is 4. So there's one answer. 7 minus 17 is -10. And -10 divided by 6 is -5/3. I just reduced the fraction there. That's all I did. Okay, so there I have two answers. And if you think back to when we solved by graphing and solved by factoring, we always had well, we typically had two answers. The factoring, we would have two sets of factors, set each one equal to 0 and solve, two answers. And that's because when you have a parabola on a coordinate plane that looks something like this, you have two places that it crosses the x-axis. So you have a possibility of two answers. So the way I would write this out is just t is equal to negative 5/3, comma 4. It does not matter what order you put them in. I typically go least to greatest, but I wouldn't mark it wrong if you had it switched. All right, let's try the next one, number 2. In number 2, it says f of x is equal to x squared plus 3x plus 18. Now this f of x, for those of you that don't remember, we did talk about this back, I think, in Unit 4. This is just called function notation. It's really just another way of talking about the dependent values, or in other words, the y values. So sometimes we use y in that place, sometimes we use f of x to tell us it's a function. It doesn't really matter, they're kind of interchangeable. The point of this is that this is the equation that you're working with. So x squared plus 3x plus 18. So now let's figure out our values here. I have a is equal to 1, b is equal to 3, and c is equal to 18. So the x squared term had a 1, this x term had a 3, the constant was 18. Those are my three values that I'm working with. Now I'm going to plug them into the quadratic formula. So I have x equals opposite of b. The opposite of b is negative 3 plus or minus the square root of. So then I have b squared minus 4 times a times c. Whole thing is over 2 times a. The entire thing, not just the radical. Drag it all the way over to underneath that opposite of b term. Now we got to simplify under the radical. So underneath the radical, 3 squared is 9. We know that. Type it into your calculator. 4 times 1 times 18, which is 72. So 9 minus 72 equal to 2, or all divided by 2. And 2 times 1 is 2. We can go ahead and take care of that and put that down as well. Okay, now finish off the radical. 9 minus 72 gives me a negative 63. So x is equal to negative 3 plus or minus the square root of negative 63, all divided by 2. So the next thing I would do at this point is I would take the square root of negative 63. Now I want you to get out your calculators and try it. Get your calculator out, type that in. The square root of negative 63, and see what your calculator tells you. When I type it into the scientific calculators that most of you have, I see something called domain error. That is not an accident. That is not you typing something in wrong. That is correct. The reason that this is an error is because this is a negative underneath the radical. If I have a negative under the radical, there is no way that I can take a number and multiply it by itself and get a negative answer. It's not possible. So when I take the square root of a negative number, there is no solution. There is no real solution to this example. As soon as you hit that negative under your radical, you are looking at no solution. Okay, so be careful with that. A lot of my students think that when they see this on their calculator, they see something like domain error on their calculator and they think, oh, I must have typed something in wrong. That's not necessarily the case. It is possible that these things have no solution. I'll show you what that looks like. If you have a coordinate plane like this, maybe you have a graph that's up here. If you have a graph that's up here, it never crosses the x-axis. It's up here and it's pointing up and it's going to keep going in that direction. Or maybe you have a graph that's down here. It's down below the x-axis, and it's going to keep going down below the x-axis. It never crosses the x-axis. So that's what happens when we get that negative under the radical. There is no real solution because there's no time that it's going to cross the x-axis and give us a solution or a 0. Okay, so we're going to stop the first half of our video there. We're going to pick it up with the second half and finish off these notes and go from there. Thanks for listening.